Howdy, everybody. Hope you're doing well whenever you are. Today was a bit of a trolley day. Um, I think I probably did really well on the leaderboards because I started pretty close to the beginning. Is this for this day? I got 31st place. I started you can see somewhere on the order of 10 minutes late, but I had a meeting I could half listen to and half do the problem. And you can see the first part of it was hard. Not hard, but it turned out to be the hardest part. And then the second part was kind of a copy and paste and a couple changes. So it just took me a few minutes to do after I read the problem. And then the third part was it felt like a troll. I don't know. I don't think I've looked at the Reddit for the day. No, I don't think I have. And but I imagine there's a lot of people that are all like, "What the heck?" Because the problem appears to be hard, and I was starting to. I knew I'm like, well, I don't really know how to do the first one, so I started kind of googling around and hey, that's why I was like, did I check the Reddit? I don't remember if I checked the Reddit or not. I don't think I did, because it's quite possible too. At the time, there weren't any answers to part 3 or a lot of them. So anyway, it was like this. Okay, well, how do I solve this? And you kind of break the problem. The problem is kind of split into two pieces, and I was kind of going between one and the other. Oh, is there a way to do this or that? And I figured out the last half. I'm like, oh, I can simplify it doing it this way, and then suddenly the problem just solves itself, and you're like, what happened? And I suspect it was done on purpose, but it was actually kind of funny. I presume it's done on purpose. And when I went back and reread the problem, I'm like, oh, is this like a hint that it was done? So anyway, what a crazy day. But it was fun and entertaining. I had a lot of fun doing it. So yeah, let's just get into it. The story is you're now like a dragon, you're a dragon duck, and they're getting ready to take off and fly, and they fly in a specific formation, and you want to fly with them, but you have to figure out how they do it. And basically they're talking about formations. So it says the groups of ducks are in random columns, and then they perform a series of exchanges until all the columns have the same number of ducks. So think about it like an equalization problem. You're trying to move ducks around, but they have a specific algorithm that you have to do it. So in the first phase, basically what you do is you go through each column pair, like windows of columns, and you say, does the left side have more ducks than the right? And if they do, you shift it over. You move one duck to the next one, and then you look at the next column, and then you move one duck to the next one. That's the way it works. And you do that until there's no more ducks to move around, right? And this actually has an interesting effect. Like if you look at it, what it does is it turns it into a here's the first round. It actually turns it into a sorted list, right? So 3, 4, 4, 7, 8. The numbers are not the same, but now the duck sizes are sorted. And so that was something I was trying to work on and figure out, what does that mean when you've got them sorted, and how does that figure into everything? Okay, so that's the first phase. And then the second phase of the ordering is you you kind of do the opposite thing. You look at two columns, and if one duck has more than the other, you shift to one over. And then so it's essentially you're doing the opposite of what you did before. You're going through the thing, and you just keep doing that, right? So it never goes back to the first phase. So you keep doing the second phase until they're all equalized. I don't actually know if this is a known algorithm, but it is an interesting uh redistribution thing where you do these passes. It's horribly inefficient, but it was an interesting thing. Anyway, they give you an example. They say these are the columns of ducks. So you have these asterisks that kind of do it. And you just go through steps, right? So in step 1, you are in the first thing, you're like, okay, 1 and 2, 1 is greater than 2, so I move 1 over here. And then you look at 2 and 3, right here, and you move, since 2 has more, you move it over. 3 and 4 don't, 3 is less than 4, the number of columns, so you don't move those. 4 and 5 is also less, so you don't move them, but 5 and 6 is greater, so you move it over. And you just kind of keep doing this. And so they give you an example. They say, here, look how it works. You keep doing this until you've slid them all over. And so it says in this example, after 6 rounds, it's now stabilized, right? So if you go through this one more time, it won't actually make any changes, if that makes sense. So that's the first round. And then the second round, you're doing the same thing, but the opposite way now. So you compare columns 1 and 2, and you say, oh, 2 has more than 1, so I'm going to shift 1 over. And then you compare 2 and 3, and 3 has more than 2, so you shift 1 over. You do that, shift, shift, shift. And you basically just keep doing this forever, and eventually round 11, you get done. For the part 1, they say, just do 10 rounds. And then tell me what the checksum is after 10 rounds. And the checksum is just the value at the column times the column number starting at 1. So it's 1 base. So 4 times 1, 5 times 2, 5 times 3, 5 times 4, 6 times 5, and 5 times 5. Or 6. 5 times 6. I think I said that right. Anyway, that's the point, is like, this is the big one, so, or this is the 10th one, so you're done. And that's part 1, right? So it's just figuring out the algorithm going this way, figuring out the algorithm going this way. So what does that look like in code? Well, we're dealing with numbers, so it was pretty easy for me to parse. I just do lines, map them to their U size, and collect. And then for me, I just followed the algorithm. I actually think there might be a way to do like a windows over, like, is there a mute window? I don't know. I haven't tried it yet. But I said, okay, well, we're going to stop at 10 rounds. So I'm going to loop the first part, the first phase, until either I haven't had any moves or I've shifted the rounds. I actually think I see kind of a little logic bug. Like, if they didn't move, I don't think we count it as a thing. That break the... Okay. Yeah, there I had a little bit of a bug. I had this in the wrong order, so I had to do the less than or equal. But the idea is just see if you've moved, go through each of the pairs. So you can see here I do from 0 to len -1. So I won't hit the last one. And then I say, hey, is the first one greater than the second? And if it is, we've moved. And now I decrement 1 and increment the other. So you're literally just following the algorithm. If I haven't moved, I break. Otherwise, I count this as a round, and I keep going, right? For phase 2, you do the same thing, but the opposite. You just say, okay, well, now move down, or for each round until you get to 10, go through all the values. If the first one is less than the second, increment the first and decrement the second, and increment your round, right? And you just keep doing that over and over and over again until you get to 10, right? So I don't know exactly what the number was in my puzzle, but you can see, like, it wasn't there. There weren't a lot of values in the input, I guess is to say it. Yeah, there's not a lot. So, and these numbers are compared to relatively small, so it's not a big deal. You literally just follow the algorithm, and magic, you have it. So how do you do the checksum? Well, after 10 rounds, I can just start at 1. So here this is my equivalent of enumerate. I think we've seen this before. It's kind of a cool way to enumerate when you're starting at 1. The reason why this works and it looks more like enumerate is that zip stops when either side is done. So it'll only ever count as many as there are in the input. But now I get my I and my N. So I just take, one counting forever, zip it with my input iter, and then I can map that to my column number by my column value, sum those together, and that gets me part 1. Not too bad, right? You can see down below that it solves really fast for the small input. Okay, so that's part 1. It wasn't too bad. Just implement the thing. I kind of had to read it for a second to like understand what it was trying to do. So I think I spent a little bit more time reading too, because the last couple of days I had comprehension issues, reading comprehension for the loss type things. So it wasn't too bad. What does part 2 look like? Well, there's actually not much to it. It says, okay, now that you've kind of figured out how to do this algorithm, do it until the flock is balanced, meaning do it until all things are equal. I actually don't think I have the changes I made to part 2 because I was playing around with part 3. I didn't save part 2 the way it originally was. But basically the idea is you just do it until all of them are equal, right? So eventually this first example becomes 5 5 5 5 5 5 5, and that means you've solved the problem, right? So instead of stopping at 10 rounds, you just go forever. And so they give you a bigger number, right? So here's a lot more numbers. And they kind of show you how it goes. And then you get your input and you're all like, oh, that's a lot of things. How long, this one's 8,000 and this one's 600,000. Is that going to take a lot of time to run? And it didn't take too long to run. It was still well in the milliseconds, but it did take a while. But you can see my code looks identical for part 2. Well, at the time it was identical, I should say. So maybe I won't show you the rest of part 2 because at the time it was actually identical. And the only thing that changed is here I had a loop. So I didn't check until the round. I just had a loop instead, and it went forever. Because eventually you won't move and it'll break. And then down here, I had like a while input iter all like I does not equal or I equals input 0. So I basically just said check as long as they're not all the same, we're going to keep doing that. And that was part 2. It actually solved pretty quick, right? So again, I think if you look at the times, it was like 4 minutes or so in total it took me to solve. Not very bad at all. Yeah, I think, and I mean, I don't know what else to say. I literally just copied and pasted and like changed this line and changed this line, and that solved the problem. So that's part 2. Part 3. Okay, so here's where the fun begins. It actually says, okay, nothing's changed. At least that's how I grokked it. It says nothing's changed. Now just do it. But you're going to do it again, and that's going to tell you when, well, it essentially says you're going to do part 2 again, but with a new set of numbers. The idea is what you're reading is it says, oh, well, while you're flying, you're going to be doing this thing, this sorting, and then when it's done, it will tell you where to land. That was like the storyline part of it. So I had kind of, some of this stuff is kind of interesting, but I had like, ignored it because I was thinking, oh, it's part of the story. It's saying here's the initial setup isn't random at all. Everything isn't random at all. Everything is arranged so the journey lasts exactly long as it takes to balance the numbers in all the bird columns. So I'm like, okay, that's an interesting story. It's essentially telling us to do the same thing over. And then I looked at the numbers. Ooh, doggy, those are big numbers, right? The difference between like this number and this number, or like this number and this number is huge, which means it's going to take forever, right? I did copy paste and start it running. I think I fixed my computer issues, and it was just taking forever. So I knew it wasn't going to. I knew it wasn't going to solve in any time reasonable because those numbers are absurdly huge. So I asked myself, like, when you're solving these problems and you just don't know the answer, or you, oh, how do I say this? You know it's like an efficiency issue. Like what I do is I start trying to see if I can come up with deductions for how to solve it. Like, oh, what can I infer from this, or what does this puzzle tell me? What is happening in the puzzle that might help me understand? Because, like, I think I've mentioned this before. Previous days, you may just be like, oh, it's a DFS with pruning, or oh, this is a Dijkstra's algorithm, or whatever. It's some kind of thing that we've seen before. It's a sliding window problem, right? And so you know you had to solve it. For me, this one wasn't clear, and it's probably my math ineptitudes because I later learned after I solved it that like there's probably some mathematical ways to do this. I was asking AI because it was just not clear to me what was happening after I solved it. Like, oh, well, I should say, how do you solve the first part of the problem, right? So actually, what I did, and maybe this is where I should get to, is I started thinking about the two phases, and I'm like, is there some kind of mathematical way to like solve these phases? So as opposed to asking myself, oh, can I figure out the problem as a whole? I break it down into two pieces and say, how do I solve this first phase, and how do I solve this second phase? And I was kind of going back and forth between the two. I think in the competitive programming, I found like uh, no, I think that was after the fact. I don't think I had figured out. I was like trying to figure out the phase one, and I just couldn't figure it out. Like, here was my thinking, like with phase one, is it was, I was like, oh, it's got to be something along the lines of, like, imagine two is here, and or one is here, two is here, and like three is here. Like, I know that, like, how do I describe these? There is like local maximums. Like, I know that these two are never going to pass here, and so I really just need to shift these, like these pieces right here over. Like, that's what I was thinking for part one. I was like, oh, I know I can like shift these over until they've equalized. And so I can just do like maybe I can shift them wholesale, if that makes sense, like the whole group of them, as opposed to doing them one at a time. And if I just if I say this one takes 8, and then there's some other thing over here that takes 4, oh, maybe I know, like, I mean, the 4 is going to happen at the same time the 8 happens. So I know the answer is there were 8 in the first pass, right? I wasn't quite getting it. I was like, oh, there's something. Okay, maybe we look at part 2 and see what's going on. Part 2 is more interesting because what you do is it's now sorted, right? So you have lines that are more like this. And I was all like, oh, okay, so like what's going to happen here? And I'm like, well, really what's all going to happen is all of these are going to move over to here. And I realized, oh, you know what you can do? You can just kind of do an average. So like, let's say the average falls along this line right here. What I know is that eventually I'm going to have to move this many in, and this many over here, and this many over here. And those are actually going to come from like here, 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 and here, right? So like, all of those are eventually going to shift over here. And so it occurred to me, like, this is the part that I actually did figure out, and this is where the troll comes in. I'm like, oh, I can actually solve this by figuring out the average, and like when it's sorted, figuring out the average and just figuring out the difference of these sizes, and that will infer how many rounds that you have to do, right? So like each round, this is going to shift here, here, and then here, and then here, and then here. Like, it's going to move over, right? Each one of these things is going to move over, and it's going to be equal to this average. And I don't think I totally understood the math exactly, but when you look at this problem, right, when you look at this sort right here, you can you actually know the answer to this, right? So this is 6, right? This is round 6, I should say, and you're going to go 11 rounds. Or sorry, you're going to go 11 rounds, and it's going to be equalized to 5. And so I'm like, okay, I need to get 5 more rounds out of this. Well, that's 1, 2, 3, 4, 5, right? If I know the average is 5, I just say how different are all of these numbers from 5, and it turns out it's 1, 2, 3, 4, 5. And this is actually, you don't have to solve it this way, but if you've ever done a prefix sum, which is like the sum of the values, and you compare that to the prefix sum of the averages, you get the same answer. You don't have to solve it that way, but like when I was reading afterwards the AI, it kind of made sense to me. I'm like, okay, yeah. The idea, again, the way to think about it is if you've like split it along the average, you know that these 7 and 8s are going to have to be redistributed over these 3s and 4s, and so you can just count them. So I actually tried that with the test examples, and it worked, and I'm like, cool. So here's what my part 3 looked like. This is part 2, so I'm kind of telling a story, I'm sorry. But here's what part 3 looked like, is I said, oh, well, if I just do my shift phase, I can then calculate. I can then calculate the shift left phase. Did I say that right? Phase 1, I still do it normally, but now I figured out part 2, I can calculate it. And so I did that in part 2 to make sure it worked. And sure enough, it worked, right? So you can see over here, I get the right answer. Over here, I get the right answer. I was like, okay, yep, I can do that for part 3. So then I copied the code over to part 3, and it solved it instantaneously, like this. I'm not joking. It solved it instantaneously. It came back instantaneously, and I'm like, what the, how did that? So I entered in the answer. I'm like, okay, well, it can't hurt to try, because I know it worked in part 2, and sure enough, it solved it. So I'm like, what? Why did that even work? Why was I able to solve it in one line, in like just making that one line of code? Because presumably the first half of the problem takes a lot of time too, right? You're still shifting numbers all the way over. Ah, gotcha. Here's the trick. You're only shifting numbers over if it already isn't sorted. Well, this stupid thing is already sorted. The troll input is already sorted. So you don't have to do phase 1. That was the joke. And I'm like, what the? Okay, you don't have to do phase 1. Great. Why is that? I mean, I don't know. Honestly, I think it was meant to be this way. And all of this talking, however many, for 10 minutes or so, is because I was looking back as like, is there some kind of hint that I missed or something like that? And I think there might be, right? When you're reading the problem, at first I thought it was part of the story, but it says the initial setup isn't random at all, as the Grand Byte Father has told you. Everything is arranged so that the journey lasts exactly as long as it takes in the column. And I'm like, oh, okay, so was that like a hint? And maybe I just wasn't paying attention to the hint, and I like lucked myself into it. Apparently I did, because that's how it solved. But yeah, the hint is, oh, it's already sorted. So you actually don't have to do the first chunk of it to solve it. That makes sense. So there you go. That was part 3. It was wild for me, because I was like, oh, how do I solve this? I don't even know. And I was trying to figure this out. Like, how do I do part 1? Okay, I can't really figure it out. How I can figure out how to do part 2. I'm like, oh yeah, okay, I think I figured out how to do part 2. And so then I go and solve it for sorry, I should say phase 2. And so I go and put that in part 2, and sure enough, it solves the problem. So I go do it for part 3, and it turns out all you have to do for part 3 then is just find the mean. You just have to do this line right here. You find the mean, and then you filter by the mean, by the values that are less than the mean, and subtract them from the mean. and then take that sum, and that's how many shifts you take. So yeah, I think this is me kind of making a note of what was happening. So I knew like my solution was really huge. I knew it wasn't going to finish, right? It just wasn't going to finish. And okay, here's another troll. They don't ever give you an actual sorted one in the example phases and say, oh, look, it never finishes. And maybe that's, I mean, you know, the puzzlers at the discretion decide what the secrets are and what the hints are, but they don't give you an example. So this P3, like I was trying some of the bigger examples, and they were just taking a long time. And it wasn't until I realized what was happening that I was like, oh, well, if I just start with phase 2, then it solves fine, right? So, yeah, but then when I'm like, LOL, the input is sorted, we can ignore phase 1. We just have to figure out how many rands it'll take to fill the gaps, get either of the values below the mean or above the mean, and sum them. That was my thinking, right? Is like, figure out, you can do it either way. I'm pretty sure you can. You figure out what the mean is, and then you either take all the ones above or all the ones below, and that turns into the number of rounds that you choose. Anyway, a crazy part 3. And again, like I said, it kind of came out of nowhere. So I did ask AI after this. I'm like, because this is one of those where someone will invariably say it doesn't solve it for a generic input of large numbers. How would you do that? And so maybe that's your like quote unquote part 4. How would you solve this like in a generic way is maybe the way to say it. And so I did kind of Google, now that I had solved the problem, I felt okay kind of Googling it and trying to figure it out. The AI seemed to think you could use the prefix sums with a convex hole. So I haven't tried this, but a convex hole, the idea of it is, this is the one I think I went. The idea of it doesn't have any pictures here either. The idea of a convex hole is can you create a polygon that will cover all of your given values, and it's normally done in like a 2D or a 3D space, right? I guess it could be in any ND space, because we would be doing it in like a quote unquote 1D space, because it's just these values. Like, how do we cover these values? You kind of treat it like a graph, but like the idea is, again, that with a convex hole algorithm, you're trying to like find something that covers all those values, and then you can essentially do the diffing. How do I describe this? The way that the convex hole is used for part 1 is you do the prefix sums of the things, and then you find the hole that does these, and that creates the graph of it. And then now that you have the average, you can like normalize it, and that will tell you, and that will give you what the sorted shape looks like. So it was a cool idea. I would have never figured this out on my own. I would have had to use AI or look around here. Again, like what it's basically doing is, like, say you have a bunch of numbers like this. Remember, they're all different sizes. What it's going to do is create a prefix sum. This is what it was saying to do. And what that has the effect of doing is it adjusts them so it always looks like this, right? It's always going to grow like this. And then you use the convex hole to like find this line right here, right? And then you can normalize it over this line. So you like normalize this thing, and it like cuts it, like it like will cut it right here over the average. How do I say this? I should now you calculate the average over that, and it gives you like it like cuts it like this, and that will now tell you what the sorted value will be. So I don't think it's like an ON operation, but it's definitely not like a you know, O takes forever operation. I don't even know what the other one was. So I haven't actually tried that. If you solved it that way, I would love to see it. That's really cool. Again, this was me. I have no idea how to do this, and it was new to me. So again, I did look it up and read it briefly, and the CP Algorithms website does have an example of solving it with a monotone chain. I think that was the one that AI suggested. I don't know which one's better or worse. Uh, but it sounds like this one is better. But it actually gives you a solution, and it's over 2D space. I think you could still solve this in 2D space, just under recognizing that like your 2D space is like the length of the thing, each of the column. That makes sense. But then that gets you to the solved state. So um yeah, and so that was the day, right? I don't know. Did you all have that crazy day? Did you like I honestly felt like I lucked myself into a solution. If I had Sometimes I like hyper focus on one part and ignore all the other stuff. And over the weekend, like for one of the quests, I think that was one of the reasons, right? Is like normally when you're doing stuff, like you should say like you like break into parts, and then and then you like like look at input, and then you like compare to known, right? And so these are like kind of like three general things, is like, can I break the problem into parts? Is there something special about the input? Or is there something I know that's similar? So like, can I mutate this problem to get it into something that I know and then solve it? Or is there something special about the input? Or can I break it into little pieces that are more solvable on their own? These are like general solving techniques that, like, at least for me, have been helpful. And so when I'm doing these things, sometimes I can hyper focus on one. Like I think I had mentioned in the previous day, it took me like 4 hours to solve the problem. And it was because I had kind of like ignored this one, and I was really focused on like these two parts of the problem. And I assumed my input was okay. And I didn't like review the input. So I could see myself becoming hyper focused on this part and like never getting to part two, and then never solving it and be like, oh, what a joke. Um, so if you did that, don't feel bad, because again, like just the previous problem, I had done the same thing. Sometimes you just luck into finding the things. Over time, I think it averages out, and some problems go faster because you solve them, some take longer. But as you like get better, hopefully the general trend is things get better over time. Who knows if that's actually happening for me, but I have fun solving them anyway. So there you go. It was a fun problem, so I definitely want to look at the solution, see what everyone said. Maybe they had it. One insight for part 3 is the input data. Yeah, that was the thing. Is like it didn't even occur to me that to look at the input, and I kind of just lucked into it. It again, actually, like then I guess if you think about it, again, I had not fully inspected it. There's the potential for me to have found it again, because I think I mean, I don't even remember my numbers, but I think I had only been working on the problem for 10 or 15 minutes. Is that right? 20 minutes? Like, no, it is about 15 minutes. Yeah. So, um, so I'd only been working on the problem for like 15 minutes or so. But yeah, if I had looked at the input, it might be like, we can ignore it. And that like actually solves the problem absurdly fast, because it means you just have to focus on that one part, the second phase of solving it. What is this? What are the facts? How do you prepare? Uh, what happens if I provide an incorrect? Can I stream? Yes. How long should I wait before I share my solution? You don't have to wait. Can I use AI? Yeah. I mean, yeah, I agree. Like with this looks like it's like I think this is like the programmers or whoever set it up. I actually don't know a lot of details about everybody code, but I do think they make a good point. There's, can you just find the solution? And sometimes you need help. It's okay to say, I just have no idea and start looking. I had no idea how to do the phase 1 thing, right? So I was actually Googling, right? I think that's okay to like Google around and say, man, I just don't know. And the reason I started Googling immediately, sometimes you sometimes you have like an algorithm where you're like, oh, I maybe it fits into this thing, and you're trying to like shape it to fit. Or maybe you're saying like, oh, can I just optimize some piece of it, and then that helps you. Sometimes though, you uh, just know you don't know, right? I think, have you heard that phrase before? That real smart people know what they don't know type thing. And so if you know you don't know how to solve this, go look for help. Yeah. I do it all the time. People do it all the time. It's okay. Don't worry about it. Um, Obviously there's certain rules if you're in like a competitive programming thing, to like equalize it because it's meant to be like your knowledge and your speed at solving a problem versus someone else's. But when you're just here having fun and learning, very cool. Uh, oh, this is cool. Godot. Oh, that's interesting. So he creates a little container for the answers and examples and then uses those as string. If you don't know what Godot is, it's like a game engine. I actually played with it a little bit this year. Tried to make a couple games for just for fun to learn how it works. I was comparing it to like Bevy and Rust. Where does it actually solve? I'll have to figure out how this works. I actually don't know how you solve it. Okay. Oh, maybe it's in some of the things. I don't know. That's really cool. Solution. So I did not get the hint. It did not check the notes for part 3. Instead, I solved it for the generic case. You can somewhat easily compute the segmentation after phase 1 and then compute the number of cycles to get to that state is similar to the logic in phase 2. Well, at least thanks to this part that all it's at. How? Okay, let's just look. I mean, part 1 looks very similar. Okay, so this may be a little bit close to what I was looking at. Was like, um is there, it looks like what they're doing is maybe there's kind of a way that you can like shift things over by larger amounts. Like if you find, I don't know if they're exactly doing this, but my thinking was at the time, could you find like some kind of like local maximum that would say, oh, I know this one's going to be like the barrier that's going to shift these over. So I do that work to shift those over. And then I can look at that maximum now and find the next local maximum and say like, oh, all these in here now are going to get filled up by that maximum. Um, and it will sort of create the graph. It looks like maybe that's what they're doing. So this solves actually different than what the AI suggested for me. After I solved it, it said something. It was talking about the prefix sum and stuff like that, which is a little different. The segment has a fixed increasing slice. I'll have to read this more to understand. Oh, did they actually ran it? Interesting. It did feel like so this is I'm sorry, I'm just not reading these out loud. This one felt like a bubble. It did feel a little bit like, oh, is this like a bubble sort? I don't know if you've ever done bubble sort before, but the idea is like you take a number and you bubble it up until it found its place, and then you take the next number and bubble it up until it's found its place, and eventually you don't bubble anymore, and now the list is sorted. And it felt close to that. Part 3 testing, second test. I knew it. Close enough. Hmm. For something so obvious, part 3. It was, yeah, this is, don't feel bad. Like, I don't think it was obvious. Yeah. Okay, so I think they're doing it the same way. Yeah, I just want to reply. sad to say I didn't go part 3 up. See how they solve it. Oh, okay. So this is the part 3 solution. And it's just find the average, calculate the difference. Yeah, these people don't feel bad. This is the fun part of problem solving. Okay, yeah. Very good. Yeah, don't if you're watching this, do not feel bad for how you solve the problem. We're all at different places, right? Some of the problems are going to be harder. Maybe you're a ninth grader taking a math class or taking a computer class, and you just have no idea how to do it. Please, for all that is lovely and wonderful, look for help. Find a way to figure it out. That's how we all did it when we were figuring it out, right? Maybe you're 60 years old and you're like, oh, I want to become a programmer, and you're like, oh, maybe this will be a fun way to do it. Look for ways to solve the problem however you can. It's what we do in real life every day. Everyone used to joke that like you just Google for Stack Overflow answers, right? I mean, but that's literally what we do when we're solving problems. If we don't know, go find someone who has solved it before and figure it out. And but don't feel bad about. I think the biggest thing you can do is to like learn some of these things, right? And these aren't all of them, but you can say like, oh, is this similar to something I know about? Is there something about the input that changed? Can you break this into like parts that are like more easily solvable? Those are things you learn as you get used to programming. But if you learn that problem solving thing, and if you ever get stuck, just look for help. That's the best I can say. It's okay to help. You know, where sometimes when you look at these like global leaderboards, you think, oh, how will I ever be like, you know, 10th or whatever, who's solved it all of these problems in 2 hours, when my quest 10 part 2 took 4 hours or whatever. I don't remember the exact number, but some absurd number, right? So just keep that in mind. These people are really good, and they've been doing it for a long time, and so you're not going to be up. You're not going to be up there with them immediately. And you just want to grow yourself, right? So compare yourself to last month or last year and ask yourself, are you doing better? And if you are, then I'm proud of you. Keep it up, and don't hesitate to look for help. That's how we learn and grow. So I don't think anyone, even like Advent of Code, I mean, you may have heard he's getting rid of the global leaderboards, and obviously it's hard to like manage a global leaderboard, but I think it makes it more interesting because it's no longer about, is it speed solving? It's, can I just solve the problem? And those who are interested in speed solving can still have like leaderboards and figure it out, do those things, right? Or maybe it just, you know, maybe you're interested in wanting to be doing it competitively, and that's great. But if you're just trying to learn, there's nothing wrong with like trying to figure it out, right? And searching for help to figure it out. So there you go. That's the lesson for the day. I lucked into it, and I don't feel bad. I giggled a little bit. It was fun. I hope you all have fun solving puzzles too, and we'll talk to you next time. Bye, everybody.